session, section 3, with the lecturer Dr. Wan Fazli, and we are students. Hi guys, say hi guys. Hi. Bye.
Assalamualaikum everyone. Today we will present about liquid extraction. So my group is Aeryn, Sarah, Anissah, and me, Nurhaziqah. Okay, first, liquid extraction is a solution extraction or separation. The aim of this process is to allow us to separate organic compound from aqueous solution that contain acidic, basic, and neutral compound. The organic solvent that we use in this method is dichloromethane, which is DCM. This is because DCM is immiscible in water, or it is solvable in water, and is an excellent solvent for organic compound. Okay. In many scientific lab and industrial field, liquid extraction is a go-to technique for separation and purification due to its versatility, rapidity, and effectiveness. This is because an efficient technique is needed to separate a specific organic compound, from its complex mixture, which is necessary in the lab and industrial purposes, such as purification of pharmaceuticals, removal contaminants for industrial purposes, and many more. Okay, so to start the liquid extraction, first we need to label 4 flasks with acid, base, neutral, and mixture. Then weigh about 0.2 gram of acid, base, neutral compound using different spatula and weighing board to prevent contamination. Then add all those compounds into the mixture flask. Dilute those compounds with 10 ml of DCM. Swirl the flask gently to ensure that the sample is properly dissolved. Then lastly, transfer the mixture solution from the flask to the separatory funnel. Okay, first, to extract acid from mixture, we need to combine the mixture solution with base solution, which is 10 ml of 5% sodium hydroxide solution, into the separatory funnel. Okay. Shake the funnel vigorously to mix the solution. This will allow the targeted compound, which is acid, to be separated from its mixture due to its solubility with sodium hydroxide solution. So as you can see in this picture, there are 2 layers. The bottom layer contains the DCM, and the upper layer contains the acid. This is because DCM is denser than water, so that's why it will appear as the bottom layer in the separatory funnel. Okay, next, run the bottom layer, which contains the DCM, through the stopcock into the mixture flask, and the upper layer, which is the acid layer, into the acid flask. Now, in order to improve extraction efficiency, we need to repeat this step again to get the most accurate result. This is to ensure that there is no extra acid compound that are left in the mixture solution during the base extraction and neutral extraction. Okay, now we'll pass to the next presenter.
Okay, so now liquid extraction of base is by pouring the mixture into a fresh separating funnel with a closed stopcock, and then we add 10 milliliter of 5% HCl into it, and then we shake vigorously and vent out the pressure by opening the stopcock slowly and face the tip of the separating funnel away from ourselves. And then we remove the top cover of the separating funnel to avoid air bubbles. From into the separating funnel. To increase the extraction efficiency, we add 10 milliliter. We add DCM layer by adding 5% of HCl into it. 10 milliliter. Then we rinse with DCM, 10 milliliter of DCM twice, 5 milliliter each flask, and the rinses will be added in the separatory funnel as well. We also add 15 milliliter, 10% of sodium hydroxide, and let it cool at room temperature. So the solution in the base flask will be the salt of the base of the hydrochloride salt. Next, moving on to neutral extraction. So the neutral from the previous extraction, the neutral compound from the previous extraction is then added with 10 milliliter of water. And after adding water, the mixture will be extracted. So once the layers are formed, the interface of two layers indicating at the meniscus level of the separating funnel are formed, meaning that the extraction already happened. So the bottom mixture in the separating funnel will be run off into the mixture flask, while the top layer will be run off into the neutral flask. Next, the results of extraction. So for acid extraction, we will obtain two solutions. The bottom will be run off into mixture flask, while the top one will be run off into acid flask. For base extraction, the bottom layer for base extraction, it is similar to acid. The bottom layer will be run off into mixture flask, while the top layer will be run off into base flask, and also will be continued in the neutral extraction. So next presenter.
Okay. I'll be presenting on health, safety, and precautions of this experiment. So it goes without saying that we need to wear appropriate PPE or personal protective equipment such as gloves and lab coat during the experiment. PPE is designed to protect us from potential hazards such as chemical splashes, burns, cuts, and exposure to harmful substances. It acts as a barrier between us and these dangers. Wearing appropriate PPE during experiments is a fundamental safety practice to protect ourselves and also ensure compliance with the safety regulations and standards. Next is separation funnel use. We need to handle the separatory funnel with care and ensure that it is properly closed and sealed during shaking to avoid leakage. When shaking the separatory funnel, we need to slowly release the pressure and by opening the stopcock and pointing the end away from ourselves and others to avoid accidental splashes. Lastly, the waste disposal. It is important to dispose of the waste solvents and extracts in the designated waste containers. Pouring them down the sink will lead to groundwater contamination, harming the aquatic ecosystem and also potentially affecting human health. There are also laws and regulations governing the disposal of waste, and improper disposal of waste can lead to legal consequences and fines. After disposing the waste, we need to properly wash the glassware. To prevent contamination. Residue chemicals and substances from the previous experiment can contaminate the subsequent experiments, leading to inaccurate results. That's all from me.
Okay, now that we have known about liquid extractions, I'm going to talk about the examples of it being applied in the industry. So first industry is the chemical industry. the liquid extraction is widely used in state industry, but I would like to take an example of caprolactam. Caprolactam is a substance that is used in the production of nylon. Caprolactam is a very relatively hydrophilic compound which can be easily separated from water using an organic solvent, such the one we use, example is dichloromethane. So second is in the food and beverage industry. The food and beverage industry, we use liquid extraction to extract essential oils, fragrance, or even flavors. How we use it is, first we take the plant and we add to the organic solvent, shake, and we will obtain the desired product. But there are some ups and downs to this method, which is in conjunction of this method, we use other separating methods to extract more purer product. And lastly is in the pharmaceutical industry, where liquid extraction is used to extract antibiotics, hormones, or other pharmaceutical substance. One of the example is in extracting penicillin from its fermentation broth. Organic solvents such as butyl acetate will be added to the fermentation broth and the penicillin will be extracted from it. Penicillin is widely used as an antibiotic to help with. Okay, that's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good evening, everyone. I am Nurul Shakiela binti Aeryn with metric number 2211742. We are from group 2. So first of all, let me introduce to you guys my teammate. So this group is being led by our leader, Fatin Najihah binti Haspa, and we have Iylia Zahirah, Nazifa Fatini, and also me myself, Nurul Shakiela. So today we are going to tell about our recent liquid extraction that we just did it a few weeks ago. So this experiment is basically about using liquids to separate different things. So, well, imagine we have a mixture of different things. So, for example, in cooking, when we have to separate egg yolks from its egg white, that means that show that in daily life we often need to use we often need to separate different things from its mixture. So, but in this case, in this experiment, we are going to separate organic compounds by using this liquid extraction. So we wanted to know if these techniques really can separate the component of liquid containing two mixtures or more. So these techniques will be useful in many industries, especially in making medicines. So I'll pass this stage to the next presenter. Yep.
Okay, my name is Iylia Zahirah binti Zahari with metric number 2214464. I'm going to proceed with the procedure for 1.1, preparation of mixture. For the first step, we are going to label 4 flasks, which is acid flask, base flask, neutral flask, and mixture flask. And for the second step, weigh about 0.2 gram of acid, base, and neutral compound using separate spatula to prevent contamination. Okay, for the second procedure, 1.2, extraction and precipitation of the acid. Okay, for the first step, by adding 5% of sodium hydroxide 10 milliliter into the separatory funnel and shake it vigorously. Run off the dechloromethane layer into mixture flask and the other layer into the acid flask. And then once the layer has separated, we can cool the acid into an ice bath and then let it dry. Okay. For the 1.3 extraction of the base and neutral, we are going to start off by adding 5% of hydrochloric acid into the extracting dichloromethane layer from previous procedure. And then we add into the separatory funnel and shake it vigorously. And then for the second step, repeat step 1 again. And then for the third step, by adding the dichloromethane layer into neutral flask, the neutral compound need to be washed by adding dichloromethane solution into the neutral flask. And then last but not least, we are going to let the neutral flask be open to evaporate the dichloromethane layer. I'm going to pass to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nazifa Fatini binti Muhammad Fauzi. So I'm going to present about health and safety precautions. So first is glove. Glove is a must wear in labs, especially when conducting an experiment, because it protects our hands from the chemical that can be irritating and corrosive to the skin. So second is lab coat. Lab coat is also a must wear in lab, especially when conducting an experiment, because it protects our body from the chemical, maybe when there's a splash of the chemical, so that lab coat can help protect our body. Second is our apparatus. So before we conduct an experiment, we must make sure that the apparatus is in good condition, meaning that it is clean and also that it have no cracks on it. And lastly, after we use the apparatus, we also must clean it so there will be no contamination. And lastly, for the health and safety precaution is washing our hands. So after conducting our experiment, even if we do wear gloves, there still might be possibility of our hands getting contaminated by the chemicals. So we have to wash our hands with soap to exclude all the chemicals from our hands. So next I will be presenting the result from our experiment. So first is the preparation of mixture. The way like just how Iylia have explained. First we added the powder of acid, base and neutral, and we add dichloromethane into a flask. We shake it, and then that's how we get our mixture. It is colorless. The color, it have no color basically. So next is extraction and precipitation of the acid. So the mixture that we get from the last preparation of mixture, we added 5% of sodium hydroxide solution. We add it into a funnel flask. We add dichloromethane, and then we shake it. And then if you can you see there's like bubbles in it? So we have to wait first until it become clear. So no, you can see the line. If you can see here, there's a line, and then we have just to extract the bottom layer of in the funnel flask to get our acid. In this picture, we have already repeated the extraction to get like better accuracy. So, okay. So lastly is the extraction of base and neutral. So to get our base, we added like 5% of hydrochloric acid solution. And then we just repeat the same step just like in our acid. To get the base, we repeat it again to get another like remaining base compound. And then lastly, the remaining after we extract the bottom layer of the funnel flask, the remaining in the funnel flask is our neutral compound. So that is how we extract all the liquid. So that is how we extract all liquid. If you can see, there's a side-by-side comparison. If you can see, our acid is yellow. It was supposed to be colorless because but since we have like impurities in our acid, so it become yellow. So but our base and neutral is okay. It's colorless. Okay, thank you. So next to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Najihah, and I'll discuss on how liquid extraction applied in industry. Liquid extraction find application in liquid extraction find application in various industries such as chemical and bioproduct, food, polymer, pharmaceutical industry, and more. Currently, various incentive techniques are being applied in the liquid extraction field to improve process efficiency. So, for example, extraction in pharmaceutical industry are widely used in the isolation of antibiotics from fermented broth, in the production of vitamins, and also in the production of drugs from naturally occurring materials. And other than that, separation and extraction are the most vital phase in the production of rare earth elements, and mostly conducted using liquid extraction method. In conclusion, liquid extraction is an important separation techniques in the industry to In conclusion, liquid extraction is an important separation techniques and with wide range application in the modern process industry. That's all from us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm An-Nur binti Safiyyah, and my group members Dhiya, Eddina, Qurratu'Aini, and Amalin. We from Group 3 will be presenting about distillation. Okay. Distillation is a separation techniques to obtain the pure component of the mixture based on the boiling points. So this experiment we utilize the difference in boiling points of the component in the liquid mixture by forcing one of the component into the gaseous state. So distillation is not a chemical reaction; it's just a physical separation techniques. Okay, our goal of this experiment is to obtain the pure component by the mixture based on our difference in boiling point. So, is distillation effectively can separate the component, and how the difference of boiling points can affect the separation. So, we do the distillation experiment to obtain the result. Okay, the procedure. Okay, first of all, we first have a neutral flask, which is we got from the liquid extraction that contain base and DCM, dichloromethane, and maybe a bit of water. So then we add anhydrous sodium sulfate as a dehydrating agent. So then the function is to absorb the water from the neutral flask. So we have only base and DCM only in the flask. Okay, next.
So my name is Dhiya, Eddina, and I'll be continuing the procedure for distillation. So next, after the anhydrous sodium sulfate is added into the neutral flask, we will gently pour the solution into the round bottom flask, this one, gently without getting any of the anhydrous sodium sulfate into the round bottom flask. And then boiling stone is added into the round bottom flask to prevent superheating and splashing when the solution is heated. Next, place the round bottom flask under the thermometer and secure the entrance with an adapter. Turn on the heat. Turn on the steam bath and let the tap water running through the condenser. Then observe the thermometer at which the DCM starts to change into a vapor, and maintain that temperature. Then after a while, when the when the liquid stops dripping in the receiving flask, you can off the steam bath, and you will be left with inside the receiving flask is the pure DCM, and inside the round bottom flask is the residue of your base.
Okay, so my name is Qurratu'Aini, and I'm going to present about the result that we obtained from the distillation process. Okay, so through the distillation process, we obtain a pure DCM, which is dichloromethane, and also in the round bottom flask, there is a residue, which is actually base. Okay, and next is health, safety, and precaution during the experiment. Okay, so generally, all of you must know that before we are entering the lab, we must ensure that we are wearing the lab coat, because actually lab coat is just like a shield to us, because it protects us whenever we are handling with chemical substance or any solution. If it spills, so it spills on our lab coat. That's why it is actually necessary for us to button on our lab coat, because it's not going to function. Our lab coat is not going to function if we just unbutton it, because if there is any chemical solution or a substance that spill on us, it just spill directly on our clothes and our skin. Next, we also need to wear gloves, because it can avoid us from get any skin irritation. Okay, next, here we must ensure that any chemical substance or solution like this are at the design place, which if we get the solution from that design place, we should ensure that it is there. We cannot just remove it simply to any other places, because some of the chemical substance can easily evaporate at any other place. Okay, and I don't know, but there is actually a paper on that design place that say don't mix the dropper with different chemical. Put it at the right place, because we cannot just simply use the same dropper through all the chemical solution. Okay, next is how to handle the separatory funnel. Okay, I know that you guys are more expert in handling this separatory funnel, but you must ensure that when you are handling with this separatory funnel, you must ensure that your hand is, your thumb is right on the stopper. You must hold the stopper tightly, and then you shake it vigorously. So when you shake it vigorously, the purpose is you want to increase the surface tension of the solution. And after several times you shake it, you must open the stopcock and release the pressure right. So when you want to run off the solution from the separatory funnel, you must ensure that you remove the stopper or the cap of the separatory funnel so that the air can easily push the solution down. And also you must ensure that the stopcock is open. Okay, and then this is anhydrous sodium sulfate that you put to absorb the water in the solution, and this is the boiling stones. Okay, so I know that Dhiya had mentioned it before, but the purpose of using or adding boiling stones in the solution is to prevent superheating when you are conducting the distillation process. And so here we must use cat clip when we are set up the distillation apparatus, because the cap clip will hold the apparatus tightly at that position. It's just like we're drying our clothes, right? When we are drying our clothes, we're gonna clip our clothes so that it will not just flown away just like that. So, and lastly is this thermometer, if you can see. This thermometer, we should place it not too dense to the round bottom flask so that, because we must ensure that it not too dense. But in this experiment, the thermometer is attached to the cap of the round bottom flask, so it is, Okay, so I'm going to pass to the next person.
Okay, next is the application of the distillation in the industry. So the first one is crude oil refining. So crude oil in the petroleum industry contains a mixture of hydrocarbon with a various boiling point. So the purpose of this distillation is to separate the hydrocarbons into a different fraction and with a different boiling range. So this distillation will be done in a distillation column, which is this one. So at first, the crude oil will be heated in a furnace. As the crude oil heated, the component with a lower boiling point will be vaporized, while the component with a higher boiling point will remain as a liquid. Then the crude oil will be introduced in the bottom part of a distillation column. In this distillation column, as the vapor rise in this distillation column, there is actually a tray. So as the vapor rises, it will cool down as it is decreasing in a temperature gradient. So the hydrocarbons with the component with a heavier hydrocarbon will be collected at the bottom of the distillation column, such as residual fuel oil, heavy gas oil or diesel, while the hydrocarbon with a lighter boiling point will be collected at the different heights of the distillation column. So next, the application of distillation can be used in a mobile steam distillation. So mobile steam distillation is a process to treat the contaminated soil, whether it is contaminated with a hazardous component or non-hazardous component. So the first one, the soil will be placed in a processor and the processor will be sealed. Next, the pressurized steam will be passes through the processor and mobilize the contaminated soil. Then the contaminated steam will be condensate, and then the air will be emission, and it will eliminate the air emission. However, in this process, there will be no discharge of the contaminated soil. Then the filtered condensate water will go through the fresh water holding tank to resupply the steam generating unit and to complete the cycle loop process. Then lastly, the treated soil will be sent back to the excavator as fill, or can be disposed at a approved disposal unit. So that's all from me. Thank you.
Assalamualaikum and a very good evening. I bid to Dr. Wan Fazli and everyone who present in this class, in this laboratory. My name is Cherradi Ashaimal Sadia binti Cherradi Muhammad Al-Habib, matrix number 2217960. We are from group 4 and we are going to present regarding the distillation. So, in this experiment, I've labeled a few apparatus that we use. For example, three-way adapter, cat clip, heating mantle, condenser, and also distillate outlet. This is the outlet. Okay. So, the idea of distillation here is we want to vaporize the DCM. So in this experiment, we use DCM, so we are allowed to use cat clip. However, if we use other solutions, so we might consider other alternative than cat clip. Next, we have to place a beaker at the end of the tube so that we will collect all of the DCM later. The idea of condenser is we want to condense the vapor. So for example, in this experiment, we're going to heat the DCM in the round bottom flask. So once the DCM is heated, it's going to vaporize upward and then goes to the left, following the tube. Once the vapor reach in the condenser, then it will meet with the cold liquid. Once the vapor meet with cold liquid, it will turn to liquid, and lastly, it will all be collected in the beaker. So the DCM will be in the beaker and the sample will left in the round bottom flask. Since DCM boil at 40 degrees Celsius and also the sample boils at more than 100 degrees Celsius, so we're able to use the distillation. However, if there's water in the round bottom flask, we have to consider, we can't use this because water boils at 100 degrees Celsius. So we can't use it. Once the cold liquid run in the condenser, the cold liquid will run from the bottom to top. And the question here is, why don't the cold liquid run from top to bottom? Is because we want to eliminate the presence of air pocket. Because if there's air pocket in this experiment, it's going to ruin the experiment. We have to place the thermometer on top of the three-way adapter to make sure that we don't overheat the sample. If we overheat the sample, there's a high possibility for the DCM to burn or even explode. Next is the problem statement. So for this experiment, the problem statement is to separate and purify the base from the sample while ensuring maximum yield and minimal energy consumption while adhering to the safety protocols. I'll pass the floor to Hanis.
Okay, my name is Hanis Fatin Nabila binti Kabir. Today I'll presenting about the procedure. Okay, first of all, we need to have a flask that contain a base inside it, and then we will combine DCM all together inside the flask, and then we will add the boiling stone to prevent superheating. And then after that, we will transfer all the liquid into the bottom flask without the boiling stone, only the liquid. And then after that, we clip the bottom flask here and the thermometer. You can refer at the picture number 4. And then we will heat all the bottom flask and then run the cold water. Next, we will, while waiting, we will observe the temperature to maintain at 40 degrees Celsius. And then lastly, we will observe the receiving flask. Make sure there's no drop of liquid so we can stop the heating, and also we can remove the bottom flask and we get our pure DCM at the receiving flask. Next, I will pass to the next presenter.
Okay, okay, my name is Nurhaziqah Hanani with Marissa with metric number 2210946. So for my part, I'll be explain about some precautions during this experiment. So firstly, as we all know, DCM is really toxic. So we have to avoid from breathing vapors and also direct contact of our skin and our eyes from the DCM. And next, just in case the thermometer that we use is broken, we have to avoid from direct contact of our skin with the mercury from the broken thermometer. So if we accidentally broke the thermometer, we have to collect all the broken pieces and spill mercury to a beaker and place it to the chemical storeroom for disposal. And next, as we all know, in this experiment, we are dealing with chemical substances such as DCM and base. So, we know chemical substance is very dangerous and can harm us. Why? Because chemical substance can enter our body through our skin and can cause irritation, skin diseases, and cancer, and so on. So in order to avoid this to be happen, we have to wear protective equipment such as lab coat and glove at all time. And in case if we accidentally spill chemical substance to our skin, we have to wash it immediately with cold water. I think that's all for me. I pass to my friend.
My name is Nurina Zaylilly, and I will be presenting on the distillation application in the industry. We have opted for the example of perfumery and fragrance industry. This is the smaller and the simpler setup on how to get the perfume, the fragrance that you want. So we have 2 chambers, one filled with distilled water, and the other one is filled with the plant materials that you want. Plant materials, also known as the biomass, it contains the oil sacs for the pure essential oil. So you heat up the water, the vapor will run through the steam, and then it heats up the biomass, and then the tiny particles of the tiny sacs will burst open, and it will let the vapor and the oil floats up to the top, and then they go through the condensing chamber that has cold water running in it, and then the cold water will help the oil and the vapor to liquidify it back, and then it will drip down, and then the essential oil will then separate it from the water because oil is much less denser than water, right? So oil at the top, water at the bottom, and then the oil will drip down from the top, and that is how you get your pure essential oil. That is all from us. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 5 and we will present about thin layer chromatography. Next, I will pass the presentation to the next presenter, Yasmin.
Our experiment today is called thin layer chromatographic, or so-called as TLC. TLC is a chromatographic technique used to determine the number of components in a mixture to identify the identity of compounds and also the purity of a compound. A thin layer of adsorbent is coated onto a baking support called a plate. By observing the appearance of a product or disappearance of a reactant, it can also be used to monitor the progress of a reaction. So in today's experiment, generally we will be using samples known as acids and neutral components and dissolve it into dichloromethane. After that, the samples on the plate together will be dipped into our developing solvent called hexane and ethanol, and also dichloromethane hexane, before being exposed to the light source to visualize the components. And further explanations will be made by my teammates during our methodology part. But I would like to emphasize that our problem statement for this experiment is to understanding the separations and identifications of compound in the mixture using thin layer chromatography. Hence, I will pass the floor to my teammates. Thank you.
Thank you, Yasmin. Then I will proceed to my part, which is tools and methodology. Firstly, we take the TLC plate and make a horizontal line about 1 cm from the top and the bottom. And then we need to prepare a solvent, which is 10 ml of solvent, which is 9 ml of hexane and 1 ml of ethanol. And then for the second solvent, 9 ml of dichloromethane and 1 ml of ethanol. And then put the solvent into the chamber, 5 ml each, and then close the lid to prevent the solvent from evaporate. And then don't forget to label the chamber accordingly. And then next, we need to dissolve our acid and neutral with dichloromethane, and then the mixture of the acid and dichloromethane too, we spot it on the TLC plate. And then next, put the TLC plate in the chamber, one for hexane and ethanol chamber, and then another one for dichloromethane ethanol. And then don't forget to close the lid and let the solvent rise for 1 cm. And then take it out and let it dry for a second, and then put it under the ultraviolet. Okay. And then we can see there's a spot here, and then we draw the spot using the pencil. And then after that, we can measure the distance from the bottom to the spot. Next, I will pass to Izyani.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Izyani binti Masayimi, and I will present about health, safety, and precaution during the experiment. The first one is, I think it was common thing that we need to wear every time we enter the lab. When we enter the lab, we need to wear the lab coat, long pants, closed-toe shoes, and gloves because it will protect us from contact with the hazard potential. And then the second one is, we cannot to overload the TLC plate because of when it overload, it will leaking, and it's difficult to visualize the separated component. And then we need to dry it completely because when it not dry completely, it will spreading and difficult, and it will spreading and distorting the spot. And then when we handle the ultraviolet, we need to wear the eyes protection because of the UV light will damage our eyes and skin. And then we need to wash the affected area. If we contact with the hazard chemical, we need to wash that with the soap and water immediately. And then the last one is, we need to close the chamber after we put the TLC plate on it because of we doesn't want the solvent become evaporate. That's all for me.
Okay, Assalamualaikum. For my part is result and discussion. So for the result, we have to calculate the RF value, and I would like you guys to ignore this calculation because I've made a mistake. So for A, we have to calculate the distance traveled by spot, which is this part. We assume that from this to this is 0.25. And then from the distance traveled by solvent front, which is B, is from this horizontal line and until this part, which is 3 cm macam tu. Lepas tu we will divide the two distance, and then we will get 0.08 for the RF value. And as you guys can probably see that for both our result is neutral, is appears invisible. This is because maybe our sample is too dilute. For the second causes is maybe because when we using a pencil, we may use a lot of pressure that make the layers of this plate become scratched, and that will make the DCM concentrated on the bottom line. So for the next is discussion. So TLC is very important in pharmaceuticals industry, which is used for the stability of drugs. TLC is also used to indicate the chemical changes in chemical natures and also the drug stability. So for the food chemistry and the cosmetic industry, TLC is used to separate, identify and characterize the different component of colors, cosmetic products, and also sweetenings and preservative substances. For the biochemical analysis, TLC is used to isolate, compare and characterize the components of compounds and metabolite from the body fluids, serums, and also blood. So that's all from our group. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Mikhail bin Abdul Rahman with metric number 2215743, and these are my group mates here. So tak nampak kan? It's okay. Oh kan? Tak apalah. Sorry. Gemuruh Okay. Oh, dari semula eh? Alah. Okay, tak apa. Boleh. Main lah. Kat sini ke?
Tak, you mesti presenter mesti kat situ. Roommate pandai lah you cari tempat dia. Tiba-tiba nak kita frame ke? Buat macam tadi.
Ya, boleh. Okay.
Tapi presenter kat sini saja. Okay.
Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Mikhail bin Abdul Rahman with metric number 2215743, and today I will be presenting on thin layer chromatography with my group mates, with my handsome group mates. So, let's get into it. Kena tekan ni, tak ingat. So, what exactly is thin layer chromatography? So, tak ingat pula. Thin layer chromatography is a chromatographic technique used to separate and analyze a mixture of compounds. So it's based on the principle of differential migration of compounds, on the stationary phase and mobile phase. So I'm just going to explain like 5 things that is maybe important for us to know. So the first thing is the stationary phase. Maybe you guys know what that is, but I'm just going to explain it. So the stationary phase is a thin layer adsorbent material, usually the silica gel or alumina, that is coated on a flat inert sheet like a glass plate or a plastic sheet. So this is the foundation of the sample that we are going to spot on for the next. And then the second is sample. So how do we apply the sample is that we should apply the sample on the near bottom of the TLC, right? So usually we spot just a small spot or a line. Sorry if you're seeing I'm trembling. So the third one is development. So for the development part is that once we apply the sample on the TLC, we put the TLC into a developing chamber in a shallow solvent, and then the solvent will climb up the TLC with capillary action carrying the components of the mixture until it reaches to the line that we already did. Like I can show you the picture afterwards. So the third one is separation. So separation is the part where it counts most, because the stronger affinity will actually move slower in the stationary phase, but moves faster in the mobile phase. So this differential migration actually is the important part where the compounds will separate from top to bottom, which one starts and finish, right? And the last one is visualization. So visualization, we can't see what we did with the naked eye. So and we can use various techniques. Like one we use is UV light, but the other, we can use chemical reagents which we can spray on the TLC and it can create small colored spots, right? So the problem statement is polarity of unknown compound can be determined. So yeah, it can be determined. It just goes like how the less affinity is just almost the same. Polarity can be determined if, like, it's just the same that I said before for the 5 things. It's just that in the first part where we choose the solvents, for known polar compounds, we can use a polar solvent. But if it's non-polar compounds, we can use a non-polar solvent, such as pure hexane. For the polar solvents, we can use such as ethyl acetate and hexane. So yeah, that's it from me. Oh yeah, give to Abang Zakwan.
So Assalamualaikum, my name is Haris Zakwan. So right now I will present the procedure of this experiment. So basically, as usual, if we want to make experiment, we must firstly prepare all the materials and the apparatus. So the first thing we must do is prepare 2 solvent, developing solvent in a flask, and each flask has 10 ml. So the first flask we will containing, the first one we containing hexane and ethane with a ratio 9:1, and the second flask containing dichloromethane, which is DCM, and ethane, hexane with same ratio 9:1. And then after that, we must take 5 ml each flask, and then put them in the chamber or each that, so that after we put the chamber, we must close the lid to evaporate, to saturated evaporate of a solvent. Then take 2 TLC plate. Okay, after to take 2 TLC plate, we must draw a horizontal line within 1 cm top and 1 cm from the bottom. And then after we draw a line, we must take that TLC plate and then put that in the developing chamber just now. And then after put that them in the developing chamber, we must close right. After before we okay. Oh, sorry. Before we put the TLC plate in the developing chamber, we must drop acid and neutral solution on the line on the TLC plate. After that, we put that in the developing chamber. Then after a few minutes after dot will rise within 1 cm from the bottom and less 1 cm from the top. Put out the TLC plate and then let it dry. So after TLC plate was dry, bring the TLC plate and then put it under the UV light, short wave UV light, to visualize the component. And then after we see the visual component, take a pencil and draw the outline or draw the shape, so that we know how a distance between the bottom and the right now shape, or how much distance it rise. Then we calculate and use a formula RF to know how effectively the rising with a different component. So this is a result after under the UV light. So we can see a different, maybe you can see, we can see the difference between acid neutral and acid neutral, which have different solution, different developing solution will rise a different distance. So the safety, health and precaution, of course basic is wearing glove. We must wearing glove to we must prevent ourselves from any solution, chemical solution. Then we also must like coat all the time to prevent any chemical solution split to our body. Then yes, after we put the TLC plate in the developing chamber, we must close the developing chamber to not developing solution. Developing solvent will evaporate. We don't want that. And then when we want to spot the acid and the neutral on the TLC plate, we use a capillary tube. But the capillary tube must clean, and we can use it for a different solution, which is for acid is for acid and neutral is for neutral. If not that, the solution will mix and we can get an error answer and result. So that's all from me. I will pass to the next presenter.
Okay, thank you, Brother Harid, for the passing. Bismillahirrahmanirrahim. Okay. The thin layer chromatography technique is a versatile technique that can be used to analyze a wide variety of samples, including solids, liquids, or even gases. And it is a relatively inexpensive and easy to learn technique. And it is widely used for production, and it is widely used in research and industry. So today, I will be presenting to all of you about the thin layer chromatography applications in two industry, which is pharmaceutical and food industry. Okay, in pharmaceutical industry, the TLC technique is widely used for production and quality assurance applications. And if we do the qualitative test, we can determine the presence or absence of a substance in the samples. And this method is basically based on the principle of the different substance will have the different affinities towards the stationary phase and a mobile phase. While if we do the quantitative test, we can determine the purity of a drug substance. And after that, we move to the food industry. And within food industry, we can use the thin layer chromatography technique to in many different applications, such as quality control and food composition analysis. And if we imagine a scenario of a canned food company, if the production team want to detect whether there is any contaminants in their products, they can use this TLC method to detect whether there is any presence of contaminants such as herbicides, pesticides, or heavy metal. And furthermore, this TLC method also can be used to develop new food products by doing the screening of desirable flavor and aroma compounds. I think that's all I'm going to say about. I'm pass to Brother Adam.
Oh, this is just short. I just want to add that for TLC, it's a good qualitative analysis for you to use TLC, but for a quantitative analysis, we better use like HPLC, which is high performance liquid chromatography or other chemical tests. So that's all from us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. We'll be representing about the recrystallization. My name is Muhammad Zuhakimi bin Zulkifli, and this is the list of our group members. Introduction. First of all, we need to know what is the recrystallization. Recrystallization is a technique used to purify the solid compound. It is one of the most useful technique and efficient to separate pure compound from its impurities. It's because the recrystallization can produce a higher purity product other than other method. Okay. During recrystallization, the impure solid compound will be dissolved in a hot liquid solution until it's saturated, and then it will be allowed to cool. After that, the crystal form will be removed from the solution by using filtration. Lastly, the crystal will be dry out from the remaining solvent, so the final product will be produced. In the experiment, we use material like acid precipitate as a impure solid compound, and hexane as our solvent. The apparatus we use is conical flask, hot plate, ice as a cool apparatus, and then the vacuum filter. Next is a problem statement. The problem statement in our experiment is to see how the impure solid can be purified using recrystallization, and also to make sure the solvent will be soluble at high temperature and will be insoluble in low temperature. Next is our application of recrystallization. Recrystallization is a commonly used purification method in various industries. For example, in pharmaceutical industry, recrystallization is used to remove and purify the active pharmaceutical ingredient or API from its impurity. This ensures the drug is of a high purity. As you know, the higher the purity of the product, the more the efficient the drug will be work. This is the picture of the drug we form from crystallization. Next is a food and beverage industry. The food industry use recrystallization to separate and purify the acetone of food additive, sweeteners, and others. For example, sugar and aspartame will be crystallized to increase the purity and to achieve a certain of crystal size. So this is the picture of the sugar that have after crystallized. Lastly is the petrochemical industry. In petrochemical industry, the recrystallization will be used to separate and purify the crude oil to produce other certain product such as paraffin wax. That's all from me. Thank you. I will pass the presentation to Bro Adam.
So we go to the critical part, which is procedure. So first of all, we have to take the dry acid precipitate that we filter in the vacuum filter in the previous experiment. So, and then we put them into the two different flasks. But be careful, we have to use spatula instead of our hand to prevent it from contaminating. And then after we put them into two different flasks, we have to add 5 milliliter of hexane into both of the flasks. And we cannot simply pour the hexane into the flask, but we have to use the small pipette and measure it in the measuring cylinder, 5 ml. So we have to make sure we conduct it in the fume hood. You know fume hood? That one, this one, the container, big one container. This is fume hood. So we have to conduct it in the fume hood. And then after we add the solvent, which is hexane, in the both flasks, we have to heat them on top of the hot plate. So the reason why we have to heat them, because hexane is an organic compound. So acid cannot dissolve easily in organic compounds. So we have to heat them up to increase the dissolve process. And then after we heat them up, until them boil, and then we have to cool both of them. The first flask we have to let it in the room temperature, and the second one is we have to immerse it in the ice water bath. So after that, we have to wait a few minutes to observe the pattern of the crystal. So before we show our result, I want you guys to guess which flask we can see clearly the crystal pattern, either in the room temperature or the ice bath. Ice. So to know the result, we go to the next presenter, Amir.
Okay, thank you, Bro Adam. Next, I will present about the result of our experiment. First of all, as we can see at room temperature, the crystal is more larger and more well defined, but in ice water bath, it smaller and less well defined. So, when we put the hot flask at room temperature, it will lower the rate of crystallization process. And then this, when the slower rate of crystallization process will lead to the more larger and more well-defined crystal due to more time of molecules to arrange themselves properly in the compound. And then the impurities in this flask tend to be excluded from the growing crystal, and it will lead to high level of purity in the final product. This method is suitable for the compound that have a reasonable solubility in the chosen solvent at room temperature. The disadvantage of the method, but when we put at room temperature, is when the rate of crystallization becomes lower, it will lead to incomplete crystallization. Next, in ice water bath, when we put the compound in ice water bath, it will increase or accelerate the rate of recrystallization process, and then it will lead to the more smaller and less well-defined crystal. This is because due to less time of compound in the molecule to arrange themselves properly, and it will just form small and other small crystal. And then rapid cooling is good because it will lead to high probability compound to trap rapid cooling is good because it will lead to high probability of trapping impurities in smaller crystal, and it will lead to high level of purity in the final product. This method is suitable for compound that have high solubility in the solvent at high temperature. So, the conclusion from this result is whether we want to choose to form crystal at room temperature or in ice water bath is depend on specific properties of compound and the desired outcome that we want, such as solubility, rate of crystallization, and crystal size. Next, I will talk about the safety and precaution. First of all, we must wear gloves, lab coat, and shoes to protect our skin and clothes from the chemical. And then we must perform this experiment in the fume hood to reduce the exposure of chemical and harmful fume and vapors. In this experiment, we must also use small amount of chemical and solvent to minimize the chemical waste. In this experiment, we do heating, and before we do heating, we must do the glassware inspection, which is we must check the flask before use, such for defect or any cracks, because the damaged flask could shatter during heating. Next, we must wash our hand after complete the experiment, and we must throw the chemical waste into appropriate chemical dustbin. Okay, that's all from us. Thank you.
Assalamualaikum. We are from Group 1. We're going to talk about liquid extraction. I'm Nurul, Fatin, Najihah, and my group mates are here is Aeryn, Safiyyah, and Amani. So, next slide. So I'm going to talk about the introduction and acid extraction. So for the introduction, so basically this experiment, we have a mixture which consists of acid, base, and neutral, and we're going to separate them. So the extraction here means by the process we use to separate the what we call it? The organic compound from the aqueous solution. Right, okay. So as we know that most of the organic compound are dissolved in water, but most of the organic compound doesn't dissolve in water, but it dissolves in organic solvent. So that the idea. So the process is by we shake the mixture, and with the mixture with the water immiscible organic solvent. So the organic water immiscible organic solvent here we use DCM, dichloromethane. Commonly we use 2, diethyl and DCM. We use DCM because the density of the DCM is larger than density of the water, so that the DCM will be on the bottom. So, which I will explain later. So when we shake the mixture in the funnel, there will be 2 layers, which is the bottom layer will be the DCM, the upper layer will be the, for example, acid. Okay, that's all for me. So I pass it to the next presenter.
Okay, so for the problem statement, okay, what is the problem statement for liquid extraction? As mentioned by the previous presenter, a mixture can't be separated easily, and we have to use one of the technique, which is liquid extraction, to separate
a component from the liquid mixture by using two immiscible solvents. Okay. The main objective is to develop a stable and repeatable process for the extremely pure and yield maximizing extraction of the targeted component. So why it is very important and why we have to do this? It is very important because this technique, which is liquid extraction, is widely used in various industries, including pharmaceuticals, petrochemicals, and environmental science. By improving the extraction process, we can enhance the product, increase the yield, and reduce the environmental impact. So this optimization can lead to this optimization process can lead to more efficient and cost-effective for more valuable of this study for both academic research and industrial applications. So that's all, and I will pass to next presenter.
Hi again. So for the next part, I talk about the acid extraction. So as we know that acid plus base, we will get acid salt, right? So from here, from the funnel, we put the mixture and we add NaO as the base. Then we put the lid on and shake. Then before we put it back on the retort stand, we need to open the stopcock because the reaction will cause heat. So yeah, we open the stopcock to release the gas. Then we close the stopcock and put it on the retort stand. So as you can see here, there will be two separate layers, which is the bottom layer, as I mentioned earlier, is the DCM, which is the DCM and the mixture, and the upper one is the acid. So under here we put the mixture beaker to push out all the mixture. Yeah. So we open the stopcock and pour it slowly. Before we open the stopcock, we need to open the lid so that it will run out smoothly. So yeah, we open the stopcock and the liquid the mixture will go into the mixture beaker and stop it and put the mixture beaker away. Then we put the acid beaker and put the acid solution. We open the okay. Then we get the acid solution there. So then we need to repeat the process to get the exact acid solution from the mixture. That's all for me.
I will talk about the extraction of the neutral and the base of the mixture. So after the extraction of the acid, we will start to extract the base. So we will start to extract the base. It's the same procedure we actually used for the acid, but the only different thing we're actually going to use, we're going to use in acid aqueous. We know that base is only soluble in organic and acid aqueous. So we're gonna actually add 5% of hydraulic acid, HCl, which is 10 milliliters into the mixture, and transfer the mixture into the separation funnel, which we will actually stamp it and start to check it. And we will actually have to release the pressure. And then after that, we will let it rest until we absorb the 2 layers of the separation mixture. So we will put the mixture back into the mixture flask, and we will put the base into the base flask, which will actually going to repeat the same steps for the base to just make sure all the base actually extracted from the mixture. So to extract the mixture, extract the neutral, we're actually, okay, the only remaining things in the mixture, which actually are the dichloromethane and the neutral. And the separation of the neutral actually have to be by adding 10 milliliters of water, H2O, and transfer the mixture into the separation funnel, which we will stamp it and start to take it away from the student and release the pressure. And then after that, we let it rest until we see the 2 layers in the separation funnel, which after that, we will just separate the neutral in the neutral flask, and the rest of the mixture, we will discard it. In the end, we will close the base for the distillation part, and we will let the neutral flask slightly open for any dichloromethane to vaporize. And now I will
so this is the result that we got from this liquid-liquid extraction experiment. So this one is the first picture, this one is the second, and this one is the third. So the first picture is acid in a conical flask. We obtain it by taking the upper layer of the mixture that was already separated layer by layer. And we get acid, and the lower part is the mixture that we're going to use to extract and isolate base and neutral. Okay, so for the second picture is the base in conical flask. This one same as base. This one same as acid. We take the upper layer and we get base. And the last one is neutral. For neutral, we take the lower part and we put it in neutral. So neutral is in this flask, conical flask.
Thank you, Sabiha, and I will continue this presentation with my part, which is safety and precaution. So for the safety and precaution, the most important things when we in the lab, we need to use lab coat and glove. This is because lab coat is compulsory. This is because when we doing our experiment, such as liquid-liquid extraction, when we want to shake the separatory funnel, the probability that the stopper, the white thing is stopper, if the stopper not closed tightly, it might be, the solution might be spilled out or spilled to our skin. So, and then if we use any chemical solution like acid or base, there's also probability that we will, the solution will get onto our skin. So we need to use glove. And then the second safety and precaution that we need to take note of is neutral labeling the flask, which is we need to label the neutral flask, base flask, and acid flask. This is because in this experiment, liquid-liquid extraction, the liquid used is colorless. So it's hard to define which one is which. So we need to take note of this precaution. And then the last safety and precaution that I will talk about is we need also to know the right way to use lab apparatus and equipment. For example, when we use separatory funnel in this experiment, we need to know how to hold the separatory funnel with the correct way. We need to, when we want to shake, the separatory funnel is turn upward, right? So we need to put our thumb at the stopper to make sure the stopper didn't leaking. And then we also need to, when we're shaking, we also need to open the stopcock. This is stopcock, the red thing. We need to open the stopcock to release the vapor pressure. And then when we want to continue the shaking, we need to close it again. Okay. And then we also need to make sure before we put the separatory funnel at the retort stand, we also need to make sure the stopcock is closed to prevent leaking again. Alright, for the last part, this is the last part, which is application of liquid extraction in industry. For those who interested in pharmaceutical industry, you should listen carefully, because pharmaceutical industry use liquid extraction to impurify and isolate some sample of drugs and elements. So, such as liquid extraction are able to separate and identify and also isolate proteins, amino acids, antibiotics, and enzymes. So it's really important in that field. Okay, for the second field is food industry. Food industry also use liquid extraction to separate color and flavor. And the last application of liquid extraction in industry is in environmental industry. Environmental industry use liquid extraction to enable them to separate pollutant from soil and water sample. That's all from us. If you have any question, you can ask us. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2 and today we will be present on liquid extraction. So our group member consists of me, myself, Akilah binti Hafizam, Siti Nurain binti Rahim, and Nurain Shaliha binti Adi. So next, what is liquid extraction? So liquid extraction is a separation technique that involves transferring a solute from a liquid phase to another based on the difference in solubility between the two liquid. So the problem that liquid extraction can solve is that how to extract a solute from a mixture of liquid when filtration and evaporation are not efficient. So for example, if you want to extract caffeine in coffee, you cannot just filter out the coffee ground or boil the water because the caffeine will still remain in the liquid. So what you can do instead is you can use liquid extraction to extract caffeine from coffee to another liquid that has higher affinity, such as dichloromethane, and then this way you can get the caffeine without losing any of it. And then in this presentation we will also show you how to perform liquid extraction of acid, base and neutral, and we will also discuss some of the safety and precautions that need to be taken care of during the experiment, and also we will give some examples on the application of this principle in the industry. So next is the problem statement. So the problem statement is that in the liquid extraction is widely used in the various industry, but there's some challenges that exist, in which exist in optimizing the extraction efficiency, minimizing solvent usage, and also ensuring environmental sustainability. So addressing these challenges may need deeper understanding on the mechanism and the development of techniques that in order to enhance the effectiveness of the process, and also to reduce environmental impact. So next is the methodology. So first we need to prepare the mixture by adding neutral, acid and base compound into all-in-one flask, and then dissolve them with 10 milliliter of dichloromethane, and then this mixture will then be transferred into a separatory funnel. And then this liquid-liquid extraction will use these three main steps, which are mixing, settling and separating, where in the mixing step, the two liquid will be shaken together according to and it will separate according to its solubility. And then during the settling step, the mixture we need to set aside the mixture for a certain time until the mixture is separated into two layers. And then in the separating part, we will use separatory funnel to separate the top and the bottom layer. So for acid extraction, we need to add 10 milliliter of sodium hydroxide into the funnel that contains the mixture that we have prepared before, and then we need to shake the funnel vigorously, and then we set for a while until it appears two layers, and then we need to extract the bottom and the top layer, where the bottom layer we need to extract in the mixed flask, and the top layer we need to transfer into acid flask because it is acid. So I give to the next presenter.
Okay, I will continue the presentation by explaining the base extraction. So basically, the base extraction starting from DCM that we already extract from the acid extraction, which is then we added the 10 milliliter 5% HCl. So then we put the two liquid in the separation funnel, and then we stopper the funnel, and then we allow it to separate into two layers. So as we can see, there is two layers. So the bottom one is HCl and the upper one is DCM. So they are not mixed together because of its immiscibility. So the bottom one is HCl, so it's located at the bottom one because it's more denser than DCM. So then we can extract the base. We extract it into the base flask. So then we can keep the same procedure again because we want the pure of the base mixture, which is HCl, in the base flask. So there is no DCM at all if we do it correctly. The next one is neutral extraction. So it also started with DCM that we already left in the funnel before this in the base extraction. So the neutral one, we mix it with H2O, which is same, which is 10 milliliter. And then we put it again in the separation funnel, and then we allow it to become two layer again. And then we extract it again until we get the natural one, which is DCM. The one that left in the separation funnel is water. So the next one, I will presenting about safety and precaution that we must adhere in the lab to avoid any accidents. So the first one is appropriate PPE, which is we need to follow. We need to wear gloves, lab coat and covered shoes. The one that we follow is to avoid any accidents such as chemical spills, especially chemical that can burn skin. So it can protect our skin and our clothes. The second one is we know the correct way to use the separation funnel. As presenting by this group before, we need to move the stopper before turn the stopcock. This is to allow the extraction to draining, the liquid is draining properly and avoid any formation of bubble, because we need to do it correctly to get a precise result. So then we need to aware about the waste disposal, which is we need to throw away the chemical that we use in the container provided, and any physical waste such as glove or tissue, we throw it in the rubbish. And the last one, the things that we usually do is wash our hands. So we need to wash our hands after we completing the experiment, and then we also need to wash all of the equipment that we have been used throughout the experiment. I think that's all from me. I will pass to the next presenter, Shah.
Okay, Assalamualaikum, and my name is Shah. I'm going to present the industrial application for the liquid extraction. Okay, so first of all, for the pharmaceutical industry, liquid extraction in the pharmaceutical industry can help extract and identify chemical compounds such as antibiotic, amino acid, protein and enzyme. Not only that, they can also extract compounds such as second metabolism. So this is a picture of essential oil from the liquid extraction, and this is from cellulose waste using liquid extraction become flavonoids. Okay, next, for the food safety, liquid extraction can help identify pathogen and allergen in our food, so that all human can eat their food healthily and safely without any harm, although they have some personal health issues. And this is the recovery of caprolactam, which we can see that if the food have caprolactam, and we can ensure that we can remove the caprolactam using the liquid extraction from our food. So moving on, as for the agriculture industry, so mainly the agriculture industry will use liquid extraction to remove herbicide, pesticide from their crops, because that surely will harm and will reduce their crops yields. So as an example, we have recovery of acetic acid from the water and also removal of phenol. Okay, so moving on, using liquid extraction in the industrial application must have their own pro and cons. So as for the pro, the liquid extraction can be used at low temperature. It is also consuming low energy, which can save energy, and also they have special design that can make the they have special designs such as the communal distillation that can make the liquid extraction. So as for the cons, as we know, we can use the common distillation for the liquid extraction. That's why it's going to take some time, and also we're going to use a large volume of substance. And because of the common distillation, they have many steps to be followed, and that's why liquid extraction will is time consuming and using a large volume. So that's all from us.
Assalamualaikum. We are from group 3. My name is Umi Kalima Rauda and my group member Habibatul Balkis and Farah Akila. So today we are going to present about distillation process, and this is the apparatus that we use in distillation process. Okay, firstly, this is heating mantle. Heating mantle used for separate DCM and base. By heating the mixture in the flask, and this is pipe we use to running the cold water from bottom to the top of condenser to prevent accumulation of water pocket. And this condenser to vapor travels through the column and enters the condenser. And distill outlet to collect the DCM, purified of DCM. And this is three-way adapter and thermometer to monitor the temperature to make sure temperature maintain 40 degrees Celsius. Okay, next, the precaution. First, use protective equipment like glove and lab coat to use use glove and lab coat to protect ourselves from potential hazards. In this experiment, we use DCM and base, so we need to be more aware. And second, monitor temperature. Monitor temperature is equally. Secondly, be cautious with heating source. And third, monitor the temperature equally when distilling, because lastly, follow the rules when getting rid of leftover chemicals. That's all from me. I will pass the next present to Habibatul Balkis.
Next, for introductions, what we have to know about the distillation process. Basically, distillation is a process used to separate the substance, which is acid, basic, and neutral, from liquid mixture based on differences in boiling points. The substance in lower boiling point will evaporate first, while the higher one remain in liquid form. In this distillation process, it involves the heating of mixture to vaporize and condense in order to obtain the purified substance. Then the problem statement. For problem statement, which is what we want to solve based on our further understanding and experiment. And our challenge is to deal with mixture containing substance with similar boiling points. And this mixture will have the constant boiling points, which will make it difficult to separate the substance. And in this case, we have to undergo the complex experiment rather than the simple one. In addition, we have to observe the boiling points in order for it not to overheat, because if it overheat, it will affect the purifications of the substance, because later in the results we will get the mixture. For example, acid mixed with water, which is not the purified acids. And apart from that, other challenge is to optimize energy consumptions and improve the overall efficiency. And lastly, the selected equipments and design parameters, which is to improve the distillation process effectiveness. And that's all for the problem statement, and I will pass to the next presenter, which is Sister Farah.
Assalamualaikum. Today I'm going to discuss about the procedure in distillation process in the laboratory. First, we're going to basify the hydrochloric acid extract with 50 milliliter of 10% sodium hydroxide, and then once you put it in the Erlenmeyer flask, and you see this white liquid, then you need to let it cool in the room temperature. After that, you have to rinse the base flask with 10 milliliter of dichloromethane. And after you rinse with the dichloromethane, you have to put it in the separatory funnel. After you put in the separatory funnel, you stop the funnel and shake vigorously to let it separate the layer. After that, when you see the layer is separated, you run off the liquid into the base flask. After that, you have to repeat the process by adding 10 milliliter of dichloromethane. And then run off again the dichloromethane solution at the bottom layer of the separation layer, combined with the dichloromethane solution that we got earlier. After that, we have to wash the dichloromethane solution in the water. What you have to do is actually adding 20 milliliter of water, and then put it in an empty separator funnel, and then run off the dichloromethane solution at the new Erlenmeyer flask. After that, after you already put it in the Erlenmeyer flask, you have to dry it with this one, anhydrous sodium sulfate. Okay, once you put it in with the dichloromethane solution, you have to filter it out and only take the liquid and put it into the 50 milliliter round bottom flask. Okay, once you put it in the round bottom flask, you have to put boiling stones. Why you have to put boiling stone? Because next, after this, we're going to set up our distillation apparatus. And we have to heat this round bottom flask in the heat bath. Yes, heat bath. And after that, we have to maintain this temperature at 40 degrees to make sure that only the DCM is vaporized. Lastly, at some point, you will see the liquid will drip from to the receive flask, and after you notice that there's no dripping at the receiving flask, you remove the receiving flask, and there you got the pure dichloromethane, and the residue left in the round bottom flask is the base. Okay, next, I'm going to discuss about the petroleum refinery, or we call it as crude oil distillation. Okay, what is crude oil distillation? Crude oil distillation is actually separating crude oil into components based on their boiling points. Okay, so basically, crude oil distillation happen at petroleum distillation tower and also petroleum fraction. And in distillation power, crude oil will be heated and vaporized at the bottom of the tower, and then the vapor will rise until to the top of the tower. But what happened when the vapor rise, they will encounter with a gradient temperature, which is higher temperature at the bottom, and also lower temperature at the top. And then the hydrocarbon in the vapor will condense at the specific height at the fractional column here, and it will form we call as fractional distinct. And as you can see, the light when they vaporize, the lighter component will rise to the top, and the lighter components such as we can extract kerosene gases at the top. However, meanwhile at bottom, we have something like fuel oil and lubricants oil, which is a heavier components of one of the extraction of crude oil. So these all components is very important to the industry and consumer users. So that's why in this era, petroleum fraction is really important to our daily life. Thank you. I think that's all from us. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh. I'm Nurhaziqah, and this is Nasha and this is Zahirah, and we are from group 4. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Nurhaziqah, and this is Nasha, and this is Zahirah, and we are from group 4. Today, our group will present about distillation. Firstly, what is distillation? Distillation is the purification process by separating each component of liquid mixture through the selective of evaporation and condensation. So, our primary goal in this experiment is to separate each component of liquid mixture based on their boiling point, because as we know, every liquids have a different temperature for their boiling point. For example, dichloromethane have 40 degrees Celsius of boiling point. So the question is, how does the distillation experiment is effectively to separate each component of the liquid mixture, and how does the boiling point of mixture affect the extraction of the liquid. So we do the experiment to know the answer. Next, I will give to the next presentation.
Okay, so before we get into the experiment, we should go through the health and safety precautions because we have to follow these throughout our experiment. So firstly, attire. Make sure to always wear the proper lab attire, including gloves, lab coat, and facial mask if necessary. Secondly, don't bring anything from outside the lab into the lab, such as food and drinks, as they can contaminate your samples, and your samples could also contaminate your food. Thirdly, make sure to dispose all the things that you handle in the lab appropriately, and don't throw any chemical liquids down the drain or down the sink, and make sure that you ask your lab technicians and lab helpers as to where you're supposed to dispose of it. Fourthly, make sure you handle all the lab apparatus appropriately and follow all the lab protocols, and make sure that all your beakers or your material, it has a label on it so it's easy for your reference and you don't mix it up. And fifthly, don't bring anything from the lab outside of the lab. So what happens in the lab, it stays in the lab. And lastly, if anything happens, if any accident were to occur or any mishap, don't panic and call the right authorities right away or ask the lab technicians to help you. Okay, so before we explain how the experiment happens and takes place, I'm going to go over the lab apparatus for distillation. So this one is the distillation flask. It's kind of like, if I were to give an analogy, this is kind of like our chemistry kitchen. And this is kind of like our stove. It heats up our pot, which is the distillation flask inside. This is a more close-up picture of it inside. And then we have the thermometer. The thermometer helps to maintain optimum temperature, as enzymes have to have their, as distillation, like we have to make sure that we have the optimum temperature. And also, like, we don't want it to get like too hot or too cold. Then we have the condenser. This is like a device which turns steam into liquid. And the condenser turns the liquid that we heated up at the stove at the start, which becomes vapor. It cools it down and brings it back into liquid. And the product comes out of the distillation outlet, which is the stuff that we collect. These pictures show the distillation outlets. Yeah. And also, other apparatus that's included is like this C-clamp here. It helps to put the pieces together and, yeah, hold it together. And also, we have a three-way junction here, like where it goes down. Yeah. So basically, it's like a little kitchen. You heat it up, you cool it down, and you collect all the good stuff. All right, I'll pass it on to the next presenter.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Atira, and I will continue our presentation, which is methodology. So these are the steps that we need to take in order to get pure dichromethane by distillation method. So firstly, we need to take 15 milliliter of sodium hydroxide and pour it into the base flask that contains base. And then immediately we will see that the solution will turn into white color. And then we add another 10 milliliter of dichloromethane into the solution. After that, this mixture, we will transfer it into the separatory funnel. This separatory funnel is used in order to get these two layers of mixture. This one. So as we all know that the denser liquid will be at the bottom layer. So dichloromethane is denser than the base. So we will extract this dichloromethane to another flask, and this base that is left inside the separatory, we'll use it again to repeat this separating process. And then after we obtain the dichloromethane, we add anhydrous sodium sulfate into the solution, because anhydrous sodium sulfate is used to absorb water contained in the organic solution. And then we take a round bottom flask and put boiling stone into the round bottom flask, because it will prevent superheating occur during the process. Okay, and then this round bottom flask, we put the mixture, the dichloromethane solution into this round bottom flask, and then we connect it with this condenser and thermometer, and then we are using 3-way adapter. So the round bottom flask will put inside the heating mantle to heat up this solution. And then after that, we need to observe the temperature, because dichloromethane has boiling point at 40 degrees Celsius. So we need to observe that after 40 degrees Celsius achieved, we need to switch off the heating mantle, because we want only the dichloromethane to vaporize. We don't want the base to vaporize also. So the vapor dichloromethane will vaporize and will go through the condenser, and at the condenser they will meet with cold water, and it will transform from vapor dichloromethane into liquid dichloromethane, and then it will go through the pipe and it will drop at the outlet. So this is the pure dichloromethane that we collect from this distillation process. So I'll pass to another presenter.
Okay, so for the result, right, in this in this beaker, we have pure dichloromethane, and in this distillation flask, we have base. We got pure dichloromethane by evaporation and condensation of the liquid mixture, and base is the residue after the distillation process. So as we can see, after distillation, we success to separate the component of the liquid mixture. That's all for me. I will pass to the next presenter.
Okay. Okay, for the last part is application in industry. So we know that distillation process have widely used in numerous or various of industries, such as petroleum refining and pharmaceutical. It is because distillation process is versatile because it can separate the components in due to their different boiling point. So this the two industries that use distillation. So the first one is petroleum refining. Okay, before that, I want to ask who wants to become an petroleum engineer? So, yay! So you must know that this petroleum distillation is a foundation in petroleum industry. So you have to take note that about this distillation. Okay, as we know that crude oil will separate into some components, which is fuel oil, diesel, kerosene, petrol, butane, and propane, based on their different boiling point. Okay, the next industry is pharmaceutical. Okay, this pharmaceutical industry they use distillation because it is a crucial step to manufacture the drugs. And then pharmaceutical use distillation for purification and for to distill out the impurities, and also to get the best medicine for our life. So I think that all from me. Thank you.
Assalamualaikum. We are from Group 5. My name is Muhammad Naim bin Muhammad Isairi, and my group members, Brother Azri, and then Brother Harid. Okay, today we're going to present about TSC. So some of you may want to know what is TSC. T stands for T, L layer, and C is chromatography. So we combine is thin layer chromatography. Okay, what's the function of TSC? First, it is to do rapid separation, and the second one is to do determine purity metals. So TSC have its unique identity, which is it require only small amount of sample to done it. Okay, so there are two important aspects in TSC. First, it is the stationary phase. The second one is the first one is stationary phase, and second one is a mobile phase. So without these two phases, TSC cannot be done. Okay, there are two types of TSC. First is a liquid TSC, liquid chromatographic. Second one is a solid liquid chromatographic. So you guys may wonder what's the difference between liquid and solid liquid. The difference is for liquid is the mobile phase and the stationary phase is both in liquid. But in solid liquid, the mobile phase is a liquid, but the stationary phase is a solid. Okay, so in this experiment, we're going to use the solid liquid chromatography. Okay. Next, for the experiment, first we need these three substances, which is dry acid, solid base, and crystal neutral. So for the precaution for this step, first we need to wear glove like this. Okay, you cannot wear just one. You need to wear both. But this is just the demo. Okay, the second is you need to button your coat here like this. Okay, Why? Because when you're dealing with acid, when you want to take acid, sometimes it might splash to your shirt. So your shirt gonna be ugly. We don't want that. So we need to button our coat. The function we wear gloves because we're dealing with acid, base, and neutral. So when we take acid, it might drop to our hand. So it might hurt you. So we don't want you to get hurt. So you wear gloves. Okay. So for the second step is we need to dilute it with dichloromethane. Why we need to use DCM? Because DCM have its unique property, which is it can solute almost all organic compound. Okay. You might ask why we need to make it to from as you can see, this is a solid and this is a liquid. Why we need to make it from solid to liquid? Because in order to make THC, we need all of these three substances in solid form. Okay, so for the next step, I'll pass it to the Brother Azri.
Thank you, Brother Naim. Now I will continue with my part. So the next step that we have to do is actually we have to prepare two developing solvent, 10 ml in a flask. So we're going to have two mixture. So for the first flask, we're going to use 9:1 ratio, 9 ml of hexane to 1 ml of ethanol. And then for the second flask, we're going to use the same ratio, which is 9:1, 9 ml of 9 ml for DCM and 1 ml to hexane. So you might wondering why we use hexane for both mixture. So hexane is actually a non-polar solvent because of its low polarity. Non-polar solvent is actually good for this experiment because it will give a good result, a good resolution to the at the end of the experiment. So we're going to mix the mixture in a flask, and then we're going to label the development chamber. We have to prepare development chamber and label. The first chamber we're going to label as hexane ethanol, and for the next chamber we're going to label as DCM hexane. And then we're going to use the lid. We're going to place the mixture that we have earlier to the development chamber, 5 ml each. And then we're going to close the development chamber by using the lid because the lid is actually helps you to prevent the solvent from being evaporated and to help the solvent being saturated inside the chamber. And then we're going to obtain 2 silica gel THC plates containing fluorescent indicator. For the first one is hexane ethanol and the second one is DCM hexane. And then we're going to label acid, base, and neutral on the THC plate, and we're going to draw a horizontal line about 1 cm from top of the THC plate and 1 cm from the bottom of the THC plate. And then please be careful not to touch the middle part of the THC plate because it will give a bad result at the end of the experiment. And then we're going to get the non-sample that we have earlier. For example, we have acid, base, and neutral, and then we're going to use capillary tube to drop the samples onto the TLC plate. So we use the capillary tube, we dip the capillary tube into the samples, and we use our finger to push on the capillary tube to prevent the samples from dropping out from the capillary tube. And then we spot on the TLC plate. For acid, we spot acid, base for base, and neutral for neutral. We spot on exactly on the horizontal line that we drew earlier. And then we have to use 3 different capillary tubes because we have 3 non-samples. We cannot mix the capillary tube with the other samples. And then we repeat the same process for another TLC plate that we have. So I think that's all for me. I will pass to the next presenter.
Okay, hello, my name is Hanis. So I'm gonna continue the next part. So after the Aziz spotted the 3 acid new time based on the TSC plate. We're gonna put in the developing chamber. Okay, one developing chamber with the hexane ethanol, another one with DCM. Hexane ethanol is the ratio of 9:1. Okay, so we're gonna let so we sink the TSC plate on each chamber, and we're gonna let the solvent to absorb to the TSC plate and let it rise up until 1 cm below the top. And then, so another thing, so we have a silica gel inside the TSC plate. So the function of the silica gel is to separate the component based on their polarity. So we know that acid, base, and neutral, they all have different polarity. So after it reach the 1 cm below the top, we gonna put it up and let it dry. Okay, so you see it's within the 1 cm. We put it up, both of them. And then next, so we're gonna put it under the UV light. So yeah, so we see that the both TSC plates show different result because of the solvent we put in the developing chamber. So we see the developing chamber with the hexane ethanol ratio 9:1. You see the base component travel the furthest. Or another thing, in TRC, we want to measure how the component travel from the bottom until the travel. So we see the base here, it travel the furthest, but the acid is quite low, but it still move. On the other hand, the acid plate from the TCM hexane of ratio of 9:1, acid is the one that travel the furthest, supposedly. So what's that? So we know that hexane, because they are separate based on their polarity. Hexane is a non-polar, while ethanol is a polar. And we know that hexane is 90% of the solvent is a hexane, is a non-polar, and the fact that base like to attract to the non-polar, the hexane, so it will travel the furthest. While the acid is still move because of this presence of the 10% ethanol polar, it will travel but not that far. On the other hand, the DCM one, the 90% of the table chamber, there's a DCM which is polar, which is the solvent that acid like to hang out with. Like acid likely want to be with DCM, so acid will be travel the furthest. So then we see this at the middle here, like there's supposed to be a neutral here. The reason why we cannot see the neutral, because neutral usually they do not fluoresce under the UV light because they do not have what SCM base have in common. They have, like SCM base they have an aromatic structure that will emit the fluorescence under the UV light, which the neutral component lacks. So yeah, we can see these are here. So yeah, after that, I thought we found so we're gonna measure the distance from below to calculate the retardation factor. Retardation factor is defined by the distance the spot move divided by the distance of the solvent move, which the distance solvent move is from the bottom 1 cm until the 1 cm below the top. So once we calculate the distance, the RF, we divide. We're gonna have the retardation factor, which is we can use to identify the component, because every component has their own unique value of retardation factor. So this way, we can identify the component with the sample, the component, the identity of the sample we use. Okay, so another thing, is there any other way to separate other than to separate sample other than method of the light chromatography? So there is another. One of it is the gas chromatography. It's quite similar to TLC basically, but the only difference in the TLC we use our liquid phase or liquid solid. Right? In gas chromatography, we use between gases. So this is make it like easier for you to separate the sample that in the gas phase in industry, because there are some substances that they are already in gas phase in the standard condition, so it's gonna be easier for the industrial to separate the gas substance. I guess that's it from Sana. Okay.
So lastly, for the application in the industry, we can use the TLC plate to identify the nature of different plants. For example, anti-oxidative, antibacterial, or antifungal. And then we can use TLC plate in food industry to differentiate different components in food. So I think that's all from our group. Thank you. Assalamualaikum.
Assalamualaikum warahmatullahi wabarakatuh. We are from group 6, consists of myself, Muhammad Izzat Firdaus, and my friend Amsha and Ameh. So today we are going to present about TLC, thin layer chromatography. So what is chromatography? Chromatography is a process to separate a mixture. So there are two types of chromatography, liquid chromatography and liquid solid chromatography. So what is the difference between those two? For liquid chromatography, both stationary phase and mobile phase is in liquid state. And liquid solid chromatography, the mobile phase is in liquid and the stationary phase is in solid. Okay, so for our experiment, we only use the liquid solid chromatography. So for the liquid solid chromatography at the mobile phase, stationary phase, the component move at a rate dependent upon the strength of interaction between the stationary phase. So the higher the affinity of the stationary phase, the compound to the stationary phase, the slower it will travel. So this our TLC plate consists of coated with the silica gel, and in the silica gel it contains gypsum. Gypsum is called as a fluorescent indicator. So what is the function of gypsum? So after we done our experiment, we will use the TLC plate under the short wave UV length, and with the help of gypsum we can see our result. Okay, so why did we use the TLC thin layer chromatography? The main objective is to find the polarity of the unknown compound. So for our experiment, first we spot the TLC plate with pencil like this, like this one. Okay, next we will after we spot the TLC plate, we will put our solvent that we already dissolved in the DCM to this TLC plate. We mark 3 spots, which is for acid, base, and neutral. Okay, then after we put the solvent, we will put our TLC plate into the developing chamber. After the solvent have rise and soak the TLC plate, we will take out the TLC plate from the developing chamber and let it dry. After we let it dry, we can put it under the UV length to measure the distance traveled by sample and distance traveled by solvent. And from this formula, we can get the retention factor. The retention factor is to identify compound and polarity of the compound. So that's all from me. I will pass to the next presenter.
For the next part, we will explain about the equipment, tools, and the methodology we use for this experiment. For the materials we use for the experiment, which is the sample of acid, the sample of base, the sample of neutral, and then dichloromethane, hexane, ethanol, developing chamber, TLC, and TLC, capillary tube, and UV lamp. So the procedure, the methodology we use for this experiment, firstly, we need to prepare the acid, base, and neutral and dissolve it with 5 ml of dichloromethane, and then we prepare for the developing solvents, which contains hexane with ethanol and dichloromethane with hexane. So 9 ml of dichloromethane mixed with 1 ml of hexane and the other developing solvent, which is 9 ml of hexane mixed with 1 ml of ethanol. Next, we move to transfer the developing solvent into the developing chamber, 5 ml each, accordingly with the label on the developing chamber. After that, we prepare the TLC and mark a horizontal line at the top and the bottom of the TLC using a pencil, and then mark 3 spots for acid, base, and neutral at the bottom of the TLC. And then we put the TLC into the developing chamber and leave it to absorb the developing solvent until it reaches the horizontal line at the top of the TLC. And then take it out and let it dry before we put it under the UV lamp to see the result of the experiment. And then we move to the health and safety precaution. So for the first, we need to use the glove when we handle a chemical substance that might make harm to us, such as maybe it will irritate our skin, or maybe some substances may be corrosive. And then we need to use the lab coat to protect our body part from any chemical substances. And then for the developing chamber, we need to close the lid after we put 5 ml of each developing solvent into the developing chamber to prevent it from evaporating. And then after we conduct the experiment, we need to wash our hand to remove all the substance we use in this experiment, we need to use long pens to prevent our leg part, and then we need to use the shoes, closed shoes, to prevent this from the substance from reaching our foot. And then after we conducting the experiment, we need to wash all the apparatus we use and put it back at the tray that have been provided by the lab assistant. And we move to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So I will be talking about the result and the discussion. So firstly, for the result, as you can see, this is the silica gel plate that has been dipped into the hexane and ethanol developing solvent, and this is the silica gel plate that has been dipped into the hexane and dichloromethane developing solvent. So as we can see from the result, the acid and base in the hexane and ethanol developing solvent, the acid and base did not move from their stationary phase, and the neutral is not shown, maybe because it has evaporated before before the UV light, before we check in the UV light. And for the silica gel plate that we dip into the hexane and dichloromethane solvent, we can see that the acid and base has moved a bit from their stationary phase, and still the neutral maybe has been evaporated. So this is because the acid and base is more soluble in this solvent, which is the hexane and dichloromethane, than the hexane and ethanol developing solvent. We can check this from the RF formula, which is the developing solvent. We can check using the RF value. If the RF value is higher, then if the RF value is higher, that means that the solution is less polar to its stationary phase. And if the RF value is lower, then it means that the polarity to their stationary phase is higher, like that. So the use of TLC in the industrial is in the pharmaceutical medicine is to check the quality of the medicine, qualitative of the medicine in the industry we used to check the qualitative of the compound in the medicine. So next is the discussion. The discussion is there any other chromatography technique that we use to find the unknown other than the TLC? So we found that paper chromatography is inexpensive, it's very cheap. It just uses paper and use the test solution, and also use only 2 solvents. So firstly, the methodology is the same as the thin film chromatography. Just put the solution into the just put the solution on top of the sheet of paper, and then you put a solvent to put a solvent that make the solvents to stay in a stationary phase, and then dip the solvent like this, dip the sheet of paper into another solvent to make it into a mobile phase, so that the solvent will move into the sheet of paper using a capillary action, and the test solution will move with the flow of the solvent towards upwards. And paper chromatography is used to separate the complex mixtures such as amino acid, steroids, and other simple organic. I think that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akil Fazli, and these are my group mates, which is Daniel. This is Daniel right here, and this is Bashir. We are from Group 7, and we will be talking about recrystallization. As we all know, recrystallization is a fundamental technique in the field of chemistry, and it is very pivotal because it is used to purify solid compounds. It involves dissolving a solid substance into a suitable solvent, and it is then allowed to slowly crystallize as it cools or evaporates. Like in the previous experiment that we did, experiment 1 and 2, to allow the solution to cool, it was put in an ice bath, while to allow it to evaporate, it was put on a hot plate. This process employs to remove impurities, thereby obtaining a pure, well-defined crystal lattice structure. In the lab manual, as we all have read it before, in the section 2.1, which is the recrystallization of acid, the steps, it outlines the specific steps involved in order for us to carry out the recrystallization process lah. Okay, next is the problem statements. As for the problem statements, there are 3 main problems that I'm going to discuss when doing this recrystallization process, which is the solvent selection, the crystallization behavior, and also the purification steps. As for the first one, which is the solvent solution, it is to investigate how the choice of solvents affect the separation and also the purification of the acid precipitate. As for the previous experiment, as we all know, we used hexane, methanol, and also water. The next one is the crystallization behavior. It is very important for us to examine the crystallization behavior during the cooling process, because the crystallization behavior will affect the rate, size, and also the uniformity of the crystal formation. Next is the purification steps. As we all know, the purification step that we used in the previous experiment, experiment 1 and 2, is vacuum filtration. Do you guys remember vacuum filtration? The one we used over there? Okay. The vacuum filtration is to separate the solution and the impurities. Yeah. And also the melting point, the use of melting point, and also TLC experiments, which is thin layer chromatography, as you guys watched the previous video. It is used to determine the purity and the quality of the crystal, I think. The final crystal product, yes. Okay, now I will pass it to my group mate, which is Bashir right here. He is the group leader, guys. Enjoy.
Shukran, Nakil. So we go to the next, which is process and the equipment that we use to make the experiment. So this is basically what we done before the experiment. Like we have neutral here, base, and also acid. And then there are some equipment that we use, but it's actually we don't see it. So we proceed to how the process happen. So the first recrystallization we can use using sublimation. So this sublimation is we use the already neutral that we get before, and then from the neutral we put it on the heating plate, and the heating plate will heating up the neutral and make to become have a smoke of sublimation. That smoke is contain neutral. So on top of that, we have test tube. That test tube is filled in ice. But before we put the test tube on the flask, on top of the flask, make sure the heating plate, make sure the flask is already hot. Because if you put test tube earlier, that the ice in the test tube will melt, and because of that, the neutral will not stick on the surface of the test tube, so we cannot get the result. And then after the smoke, all the smoke go and stick on the surface of the test tube, and then we scrape the recrystallize that contain on the surface using the spoon. Yes. So sorry, because this error here, so this not tak ada kaitan . So next, we other than sublimation, we can recrystallization of acid using this method . So first, we put the salicylic acid as what we want to recrystallize, because what interesting of salicylic acid, from in room temperature, the phase is solid, but we after we heating up, it will become vapor, and after we cool, it will become solid again. So so the step is we put a little bit of salicylic acid and a little bit of water, and then we make it to flash. So we want to check the difference, and heating the two flash on the heating plate until it boils. And then after it boils, we cool it. We cool the one in ice bath, and other one is just on the table because we want to make a different result. So so that is the step for recrystallization of acid. So the result of sublimation before the acid. So the sublimation of neutral before that, we have like non-structured crystal like this but this is not our real group, but it's some sort of like this So this is the result of recrystallization of acid. So I will pass with other presenter.
Okay, Bismillahirrahmanirrahim. So here are the result of our group. The crystallization did not work, or our crystallization did not work because of the ratio between water and salicylic acid does not proper. So for the second one, we can see the result of crystallization when we put in ice bath. It is because the molecule did not have time to gather because of the intermolecular force reduced, the strength are reduced. So when we put it on the table, the structure or the structure have a nicer form. It is because the molecule have the time to gather. So for our discussion, usually these three industry, which is agrochemical, pharmaceutical and food industry, will use crystallization. It is because they want to obtain a high purity crystalline from a narrow distillation from solution. So we can take for an example of food industry, they want to provide human with lactose and lysine to consume. Okay. So the next one is safety and precaution. So before doing experiment, we must wear lab coat to prevent our shirt from dirty, and then wear proper shoes. If we wear sandal, it is comfortable but not safe. And while doing experiment, we must wear gloves. So don't do this. And then do not mix any chemical reactions, especially when we want to mix the acid and water. And then after experiment, do not throw chemical into sink when we clean the apparatus. And lastly, wash your hand to remove the chemical. So that's all from me. Thank you.